Hello. Welcome to our presentation about the performance of a corrugated carton. Corrugated cartons are primarily used as a secondary packaging medium and are also known as shippers. As in all types of packaging, its main purpose is to protect its contents. In simple words, the role of a corrugated carton is to ensure that the product reaches the consumer or retailer in the condition intended by the manufacturer of the product. In order to ensure this, the carton goes through a lot of planned and unplanned stages or conditions. The first and longest stage in a life cycle of the package is storage. This is where it spends almost 90% of its life. The carton are stacked and stored in warehouses or godowns. This is also where 95% of the problems or performance issues occur. Every one of us has surely seen a warehouse with stacked cartons. At the top of the stack, everything seems fine, but as you look down towards the base of the stack, you will see a badly bruised, damaged carton about to collapse. Glance around and you will probably find the same situation in all the stacks across the warehouse. Is it a coincidence? Of course not. The carton is simply not strong enough to withstand the load of the stack. Ask any layman, why does the lowest carton look in a bad shape? He will promptly respond a stack weight is more than the carton's strength. Now ask a packaging or quality control man, what is the solution? A vast majority will reply, increase the bursting strength specification. Why bursting strength? If bursting was a problem, why only the lowest carton is affected? If bursting strength was the culprit, even the top carton should have burst open. In fact, the lowest carton has not burst at all. It has just gotten compressed. Even if the lowest carton has burst, it must have burst open, because the carton collapsed and then pushed the product against the walls of the carton. Very rarely will you find the products themselves pushing the carton walls from inside and making the carton burst. So, if everyone understands that the carton failed because of stack load, then it is a problem in compression strength and not bursting strength. If that is the case, why are we running behind the wrong parameter, called bursting strength? A large section of the people in this industry do not possess the correct and complete understanding of the subject. They either are or try to act ignorant. They will follow what is being done for the last 50, 60, 70 years and will resist any change in their systems. Then there is a class of people who are running the industry with incorrect and partial information. I dare say that these people with partial knowledge are more dangerous than the totally ignorant ones. Another segment of people exists who understand the issue very well, but will not want to go against age-old practices of the industry. Example: a packaging professional who is a consultant to the company will not try to change their age-old practices. He may think,
what if the management does not like my idea, and I lose the contract?
A packaging development employee will probably think,
I am here in this company for 1, 2 or 3 years. Why should I bother to go against the trend?
A corrugation unit owner will say,
I know how to improve the quality, but why bother? The buyer is giving me wrong specifications. And I am supplying whatever he wants. Let it be the way it is, for as long as possible.
I wouldn't say these people are totally wrong. After all, who would want to swim against the current and bring in new ideas? Who will do all the explanation work? And the bottom line is, why fight the system?
Everybody loves bursting strength.
Testing equipment suppliers love bursting strength because it sells like hotcakes. Corrugation factories love bursting strength because the equipment is small and cheap. And more so, because it is easier to manipulate. The buyers are either ignorant or are not willing to bring about a change. No one is willing to put the foot down and say, hey, you have fooled me enough, give me real quality. Give me performance-based quality. Give me stack load capacity or compression strength. Smarter companies worldwide have already dumped bursting strength and adopted edge crush test and box compression test as a better representative of box performance quality. Why are you still following the wrong parameters?
What is performance quality?
Quality parameters or specifications are of two types: material quality specifications and performance quality specifications. Material specifications are those parameters which define the quality of the material used. Performance specifications are those parameters which define the quality of actual performance of the package or packaging material. Many material specifications may also directly affect the performance of the package. Box compression is a performance quality test. Bursting strength is a material quality test. International standards, like TAPI T810, say the bursting strength of combined board is primarily an indication of the character of the materials used in manufacturing a fiberboard box, and has value in this respect. On the other hand, it gives no direct information regarding the ultimate performance of design or construction of the finished container, and correlates very poorly, if at all, with most of the performance values of the container. In fact, studies suggest that box compression strength and bursting strength may not be related at all. A high bursting strength does not always indicate a high box compression strength.
Where does the board get its strength from?
I am sure all of us have performed the below experiment in our school days. If not, it's not too late now to take a sheet of paper about 1 inch high and 6 inches wide. Now hold it straight and place a glass of water or any other weight on it. What happens? Obviously, the paper won't take the load. Now fold the paper in zigzag fashion. Hold it straight and again place the same glass of water or weight on it. What happens? The glass stands comfortably on the zigzag paper. Coming back to our subject, the fluting or the wave-like structure in the middle of corrugated sheet is nothing but the zigzag structure you just saw in the experiment. We saw that a straight sheet of paper cannot take top load, whereas a wavy or zigzag structure can easily take heavy loads. What this implies is that, in a corrugated sheet, the load is actually taken up by the flute, and the liners are provided just to keep the flute straight. Now, in a BS test, the rubber diaphragm punctures a hole through the face of the corrugated board. The resistance offered by the board is called bursting strength. Studies suggest that the liners give 100% contribution, and the fluting gives 0 to 33% contribution to the board BS. Example: if I use 3 kg per square centimeter paper as liners and 3 kg per square centimeter paper as fluting, my board BS will be equal to 7 kg per square centimeter.
How can someone manipulate BS? How can he give a higher BS without giving a better box quality?
Let us take an example. I have a 3-ply or single wall carton with the following structure. Inner liner is 100 GSM with 3 kg per square centimeter BS. Flute is 100 GSM with 3 kg per square centimeter BS. Outer liner is 100 GSM with 3 kg per square centimeter BS. Combined BS will be 7 kg per square centimeter BS, as described earlier. It is known that for a particular quality of paper, the GSM is proportional to its BS. For example, 110 GSM paper will have higher BS than a 100 GSM paper of similar quality. Now, if I want to increase the BS, I must increase the GSM of both liners. To economize on cost, I decide to decrease the GSM of the flute. The new structure is as follows. Inner liner is 110 GSM with 3.3 kg per cm square BS. Flute is 80 GSM with 2.4 kg per cm square BS. Outer liner is 110 GSM with 3.3 kg per cm square BS. Combined BS of the new structure will become 7.4 kg per cm square. This is 5.71% increase over the original BS. As you can see, by manipulating the GSM, and hence the paper BS, I have increased the board's combined BS. Since paper is sold in terms of GSM and BS values, the price of the material has more or less remained unchanged. My carton's bursting strength values are now almost 6% higher. Unfortunately, what I have done has weakened the backbone or fluting of the board, and hence my carton will now withstand even less loads. A corrugator's approach will be:
I know the compression values will fall, but since the buyer of the carton has specified only the bursting strength, and I have satisfied his requirement, I should be least bothered if the carton survives a stack load or not. My carton will pass their test of bursting strength, and I will get my money.
With the above example, I have tried to prove that BS can be easily manipulated. Going ahead, if I want to improve the compression strength, I need to concentrate on the fluting, more than the liners. My corrugating rollers must be in good condition, the fluting GSM should not be sacrificed. Liners are important too, as they have to keep the structure in proper shape, and also protect the package during drops, abrasions, etc. The pasting machines should also be in a good condition. So basically, improving BCT is not as simple as increasing GSM. It means improving the entire production process, and not just structure manipulation. If the flutes are formed and pasted properly, the final product, the corrugated carton, will obviously be of great quality. If the rollers are worn out, or the pasting is not efficiently done, it will have great impact on the quality. Hence, when the buyer says to the corrugators, increase the BS, the corrugator is happy to oblige. But when the same buyer says, increase the compression strength, the corrugator becomes sad. He now must improve the quality throughout his production process, and manipulation just won't work in this case. So, should I stop specifying BS as my specification? Of course yes. USA and many developed countries did it 30 to 40 years ago, isn't it high time you did it too? In India and probably in many other countries too, we go a little overboard when it comes to controlling our specifications. I have seen buyers who tell their suppliers, not only the combined BS, but also the BF of each paper layer, the GSM to use, etc. Why do we do such a thing? The corrugator probably has years and years of experience in what he is doing. Why are we teaching him how to make a good carton? I am sure all of us go out to a nice restaurant once in a while to have our favorite food. Have you ever gone into the kitchen and told the chef that I want a plate of pav bhaji or chole tikki, wherein you should use 3 potatoes, 1 onion, 2 tomatoes, 2 pinch salt, 1 pinch red pepper, blah 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 blah? I don't think so. We simply want good quality food. We have faith that the chef has enough experience and business sense to give us what we want. Similarly, when we deal with our suppliers, we should be bothered with what we want and not how he achieves it. Adopt the KISS or keep it straight and simple concept. Tell the supplier that you want a carton of ABC size, which should have a minimum compression strength of XYZ kgs. That's it. Tell him I don't care what GSM or BS you want to use. The carton should have the desired compression strength, and should be economical too.
How do I specify or calculate the desired compression strength of a carton?
Many a times, people get confused between a compression strength and a stacking load. Compression strength, or CS, is derived from stacking load. Stacking load is the amount of physical load that a carton is expected to take during any point of its life cycle. Firstly, check if the stack height of the warehouse is the same as the transportation. If different, which one is higher? Use it for calculations. The below sketch shows the calculation of a stack height of 10 cartons, where each carton weighs 20 kilograms. We now know that 180 kilograms of stack load will come onto the lowest carton during warehousing or transportation. If compression strength of the carton was equal or less than the stack load, then the lowest carton would surely collapse. Hence, compression strength is equal to stack load multiplied by a safety factor, usually between 2 to 5. Below is an approximate method of calculating your safety factor. How far will the package travel from the factory? How long is the package supposed to be stored in a warehouse before it reaches the consumer? Is the product fragile? If the carton fails, is the product's primary packaging designed or capable to take loads? For example, jam bottles are glass and can take loads. Wafer pouches cannot take load. Tube lights are very fragile and cannot take loads. Is the product expensive or hazardous? Is the product for export? Or how big or important is your brand image? Now give marks to all 5 questions on a scale of 1 to 5, then calculate the average and round it off to the next higher digit. Disclaimer: the above is only a rough illustration of how to calculate the safety factor to find out the desired CS specification. The method and values shown above are not standard and may not be applicable to all types of products and packages. The above information is generic only and may need some refinements or adjustments to suit your individual requirements.